There is a building still partially standing in present-day Iraq. It is over 2,500 years old. The lower foundation courses, the parts that sat in wet ground in contact with seasonal flooding from the Euphrates River, have not cracked. They have not delaminated. They have not allowed water to migrate into the structure in a way that destroyed them. Archaeologists who studied the site found something unexpected in the mortar and the joint material between the brick courses. Bitumen, natural asphalt, applied in layers, worked into the joints. In some areas, mixed with reed matting for additional mechanical reinforcement. This was not an accident. This was the engineering standard of Mesopotamian construction for over 2,000 years. The Babylonians, the Assyrians, the Sumerians before them, every civilization that built in the river plains of what is now Iraq understood something that modern residential contractors charge you $8 to $15 per square foot not to tell you. Water does not penetrate a properly bitumen-treated foundation, not seasonal groundwater, not hydrostatic pressure from a high water table, not the freeze-thaw cycling that destroys concrete basement walls in the American Midwest every single winter. And the material that accomplished this costs roughly $40 per 5-gallon pail. It requires no specialized equipment. It can be applied with a brush. It has been doing exactly this job without interruption in human construction for 5,000 years. I want to show you what it is, where it comes from, exactly how it was used, and why the version your grandfather would have recognized on a job site has been quietly replaced by something that costs 10 times as much and needs reapplication every decade. Because what happened to natural asphalt waterproofing is one of the clearest examples I have found of useful knowledge being made commercially invisible. What natural asphalt actually is. Most people, when they hear the word asphalt, think of road paving, black pavement, hot mix, trucks and rollers. That is a processed industrial product, petroleum asphalt, manufactured from crude oil refining residue and engineered for load-bearing traffic surfaces. Natural asphalt is different in origin, though chemically related. It forms when crude oil seeps to the surface of the earth and the lighter, more volatile components evaporate over geological time. What remains is a dense, viscous to solid material, predominantly bitumen, that contains naturally occurring resins, waxes and mineral compounds embedded during its slow formation. The most significant natural asphalt deposit in the ancient world was at a place called Hit on the Euphrates River in what is now western Iraq. Ancient sources called it Esir or Kupru, depending on the language. Greek writers used the word asphaltos, from which our modern term derives. The deposit at Hit was so productive and so consistent in quality that it supplied construction projects across Mesopotamia for millennia. It was traded, it was taxed. It was listed in administrative records found at Ur and Nippur as a standard building commodity alongside timber, reed and fired brick. The chemical reason natural asphalt works as a waterproofing material is the same reason modern bitumen-based products work. Bitumen is a complex mixture of hydrocarbons that is inherently hydrophobic. It does not form hydrogen bonds with water molecules. Water does not penetrate it, does not swell it, does not degrade it chemically under normal conditions. At the same time, bitumen adheres strongly to masonry surfaces, stone, fired brick, mud brick, because it is fluid enough when warm to feel surface irregularities at the microscopic level before setting into a continuous impermeable layer. Natural asphalt from geological deposits is not chemically identical to modern petroleum-derived bitumen, but the waterproofing mechanism is the same.
What differs is everything else. The naturally occurring additives, the lack of industrial processing, and the long-term behavior under UV exposure and temperature cycling that archaeologists have been able to observe across actual preserved structures spanning thousands of years. How the Babylonians actually used it. The archaeological record from Mesopotamian construction sites gives us specific technical information about application methods. This is not guesswork or inference from mythology. Excavation reports from Babylon, Ur, Nippur, and Uruk describe bitumen use in enough detail to reconstruct the actual practice. For foundation waterproofing, natural asphalt was applied in one of three ways depending on the application context. The simplest was direct surface application. Heated bitumen was spread over the exposed face of a foundation course with a reed brush or a paddle-like wooden tool. The material was worked into the surface while still warm enough to flow, filling pores and surface texture. This was used on vertical foundation faces and on horizontal courses at the ground-soil interface. The second method involved mixing bitumen with an aggregate, most commonly crushed fired brick or fine grit, to produce a mortar-like material. This bitumen aggregate mix was used as the actual bonding mortar between brick courses in sections of a building subject to water exposure. The Ishtar Gate of Babylon, sections of which survive to this day and can be seen in the Pergamon Museum in Berlin, shows this method clearly. The lower courses use bitumen mortar. The upper courses, above the historic floodline, switched to lime mortar. The Babylonian builders knew exactly which zones needed waterproofing and applied the appropriate material only where it was needed. The third method was the most technically sophisticated: reed mat reinforcement. Woven reed mats were laid over a foundation surface, then saturated with heated liquid bitumen, applied over and through the mat.
The result was a composite membrane, a bitumen layer, mechanically reinforced by a fibrous matrix, preventing cracking under differential settlement. This is functionally identical in concept to the fiberglass or polyester fabric reinforcement used in modern torch-applied bitumen membrane systems. The Babylonians were doing it with reed and raw bitumen somewhere around 2000 BCE. The Royal Cemetery at Ur, excavated by Leonard Woolley in the 1920s, contains burial chambers where the floor and lower wall surfaces were treated with bitumen for moisture protection. These chambers were sealed around 2500 BCE. The bitumen treatment is still present and still continuous on the surfaces where it was applied. That is not degraded. That is not cracked through. That is 4,500 years of intact waterproofing in a burial environment. If you need a field test result, that is your field test result. Herodotus, writing in the 5th century BCE, described the construction of Babylon's walls and documented the use of hot bitumen as mortar, noting that the material was brought from a source 8 days' journey away, which corresponds geographically to the heat deposit on the Euphrates. He was observing a construction practice that had already been continuous for over 2000 years before he wrote about it. The unbroken chain to modern times. The use of natural bitumen and processed bitumen for waterproofing did not disappear with Babylon. It transferred. Roman engineers used bitumen extensively. Pliny the Elder documented it, and archaeological excavation of Roman sites in North Africa, the Near East, and Britain has confirmed bituminous waterproofing in bath complexes, cisterns, and harbor structures. The Romans who built the bathhouse at Bath, England, a structure still standing and still largely watertight after nearly 2000 years, used lead-lined channels and bituminous sealant at the stone joints. In medieval Europe, pitch, a related material derived from heating wood or coal tar, was used for waterproofing wooden structures, boats, and masonry joints in wet environments. The technology was less refined than what the Babylonians had done because the geological bitumen deposits of the Near East were not available in Northern Europe, but the understanding that a hydrocarbon-based material could create an impermeable barrier was never lost. It persisted in shipbuilding, in barrel making, in the maintenance of stone walls in wet climates. In North America, natural asphalt deposits were known to indigenous peoples long before European contact. The La Brea tar seeps in what is now Los Angeles were used by Chumash and Tongva peoples to waterproof canoes and seal baskets. Pitch Lake in Trinidad, the world's largest natural asphalt lake, still active and commercially productive today, was encountered by Walter Raleigh in 1595. He recorded in his journal that he used the material to recaulk his ships before continuing his voyage. A tar lake in the Caribbean, and the European explorer immediately recognized it for what it was and used it correctly. That is how well established the knowledge was. By the 19th century, natural asphalt from deposits in Switzerland, France, and Trinidad was being imported into Britain and the United States for use in pavement, waterproofing, and roofing. The Trinidad Lake Asphalt Company was formally established in 1875. Swiss asphalt, known as Val de Travers asphalt, was used to pave the first asphalt road surface in Paris in 1858 and in Washington, D.C. in 1876. The building trades of the late 19th and early 20th century used coal tar pitch and natural bitumen for foundation waterproofing as a matter of routine. Application was direct. The material was heated in a kettle, carried to the application point, and brushed or swabbed onto masonry surfaces. Skilled workers called pitch applicators or tarmen were a standard part of commercial and institutional construction crews. This is documented in American construction trade journals from the 1890s through the 1940s. The knowledge was not secret. It was not rare. It was simply the way foundations were waterproofed. What replaced it and why? Starting in the 1950s and accelerating through the 1970s, the residential and light commercial waterproofing market began a shift away from hot-applied natural and coal tar bitumen toward a proliferation of new product categories: rubberized asphalt sheets, polymer-modified bitumen membranes, crystalline waterproofing additives, liquid-applied polyurethane and acrylic coatings, dimple matte drainage boards, and eventually the ubiquitous polyethylene sheet membrane that you will find specified on almost every residential foundation drawing produced in the United States in the last 40 years. The reasons for this shift were not primarily technical, they were economic and logistical. Hot bitumen application requires a heating kettle, a trained crew, and a working process that has real hazards. Molten material at temperatures between 300 and 400 degrees Fahrenheit is dangerous, and the learning curve for doing it correctly is not trivial. Sheet membrane products could be applied cold by unskilled labor, required no equipment beyond a roller and a utility knife, and could be specified, purchased, and installed by a general contractor without any subcontractor specialization. Sheet membrane products also had something natural bitumen could never have: patent protection. You cannot patent a geological deposit. You cannot generate licensing revenue from a material that has been in continuous use for 5,000 years and is described in Herodotus. But a rubberized asphalt sheet laminated to a polyethylene film carrier, sold under a trade name, distributed through a national supply chain, and backed by technical specifications tied to a proprietary installation system, that is a business. That generates margin at every point in the supply chain. That can be advertised in trade publications, certified by industry bodies, and written into building codes by people who have a financial relationship with the companies making the products. That process is not a conspiracy. It is just how markets work when simple things can be replaced by patentable things. The result is the same regardless of intent. The simple thing becomes invisible, and the patentable thing becomes the standard. And the standard gets written into the building code, and the building code is what contractors follow. And contractors are what homeowners call. And homeowners pay for whatever the contractor recommends because they have no way to evaluate it independently. The polyethylene sheet membrane that became standard on residential foundations in North America has a service life under real-world conditions of 20 to 50 years. After that, the polyethylene film becomes brittle, develops microperforation from backfill movement, and eventually fails to maintain a continuous barrier. The rubberized asphalt adhesive layer delaminates at cold temperature extremes. The system that replaced 2,000-year-old continuous practice has a shorter service life than the foundations it is supposed to protect. The bitumen-treated foundations at Ur are still intact after 4,500 years. The polyethylene membrane on the 1985 basement may already be failing underneath the drainage board right now, invisibly, and the first evidence will be a chalky white bloom of efflorescence on the interior block wall, then a slow seep along the floor wall joint, then a contractor quote for excavation and rewaterproofing that begins at $15,000. The formula and how to apply it today. Natural asphalt and bitumen-based waterproofing products are still manufactured. They are still available. They are not obsolete. They are simply not heavily marketed to homeowners because they are inexpensive, durable, and their active ingredient cannot be owned by anyone. The product category you are looking for is called fibered foundation coating or asphaltic emulsion. It is available from several manufacturers. Karnak, Henry, and Gardner are common brands in the United States, and equivalent products exist under other names depending on your region. The fibered versions contain short, asbestos-free cellulose fibers that provide the same mechanical reinforcement function that reed mats provided in Babylonian construction. Dimensional stability, crack bridging, and resistance to substrate movement. The cost is approximately $35 to $50 per 5-gallon pail. A 5-gallon pail covers approximately 50 square feet at the recommended application thickness. For a new foundation before backfill, the application process is straightforward. The concrete or masonry block surface must be clean and free of standing water, but it does not need to be bone dry. Asphaltic emulsion tolerates damp surfaces, which is one of its practical advantages over polyurethane-based coatings. Apply with a stiff bristle brush, working the material firmly into any surface irregularities, gaps in the block, mortar joints, or honeycombing in poured concrete. 2 coats, allowing the first coat to become tack-free to the touch before applying the second, gives a total dry film thickness of approximately 60 to 80 mils. The result is a continuous, monolithic barrier with no seams, no mechanical fasteners, and no points of stress concentration where failure typically initiates. For an existing foundation showing water intrusion, early-stage efflorescence, or surface dampness after rain events, the same product can be applied after surface preparation. On poured concrete, a wire brush removes loose material and latents. On concrete block, any deteriorated mortar joints should be pointed with hydraulic cement before application. The asphaltic emulsion will bridge hairline cracks up to approximately 1/16 of an inch, which covers the majority of the non-structural cracking found in residential foundations. For areas subject to sustained hydrostatic pressure, a foundation wall where the water table rises above the floor slab level during wet seasons, the traditional reinforcement method remains valid and recommended. Apply a first coat of asphaltic emulsion and allow it to become tacky. Embed a strip of fiberglass window screen fabric or similar open weave material into the wet surface, pressing it flat with the brush. Apply a second coat over the embedded fabric. The resulting composite membrane is dimensionally stable and crack resistant in a way that unreinforced emulsion cannot match under movement conditions. This is exactly the reed mat principle the Babylonians used. The materials are different. The engineering logic is identical. Total material cost for a standard residential foundation perimeter, approximately 120 linear feet with a 4-foot exposed wall height below grade, runs to 8 or 10 5-gallon pails, a total material cost of $400 to $500. The contractor quote for torch-applied modified bitumen membrane on an equivalent job, which is the modern premium proprietary equivalent of this system, begins at $8,000 and rises depending on access, surface preparation requirements, and drainage board installation. The chemistry performing the waterproofing function is the same in both systems. The material cost difference is the price of not knowing what the Babylonians knew. One safety note that matters: asphaltic emulsion in its water-based form is low hazard. It has low volatile organic compound content, requires no open flame, and is safe for residential application with basic skin and eye protection. Solvent-based asphaltic products, which are still sold for specific applications, including above-grade flashing work, require adequate ventilation and are not appropriate for use in enclosed below-grade spaces with limited air circulation. If you are working on a foundation wall in a confined trench, use the water-based emulsion product, not the solvent-based version. The label will indicate clearly whether the carrier medium is water or petroleum solvent. Read it before purchase, not after. This distinction matters both for personal safety and for adhesion performance in wet or cold conditions, where solvent-based products can fail to cure properly. Closing. The building at Babylon that survives today is not a monument to lost technology. It is a monument to the fact that some problems were solved correctly the first time, and the solution was so inexpensive and so accessible that no one could figure out how to make money from it in perpetuity. Bitumen waterproofing is not folk knowledge. It is not Amish tradition or old world craft. It is documented, tested, archaeologically verified, peer-reviewed in the literature of ancient material science, and chemically understood at the molecular level. The reason it disappeared from residential construction guidance is not that something superior replaced it. It is that something more profitable replaced it. Those are not the same thing. A 5-gallon pail of asphaltic emulsion, a stiff brush, 2 coats. That is the foundation waterproofing system the Babylonians would recognize. That is what Roman engineers used at Bath. That is what American builders used routinely until the post-war product revolution made it commercially inconvenient to recommend. Your foundation is either going to be dry or it is not. The material that makes it dry and keeps it dry for a century costs $40 and has been proven over 5,000 years of continuous use on 3 continents. The system that positions you to keep purchasing, reapplying, and eventually excavating for complete re-waterproofing costs 40 times more and has a documented service life shorter than the structure it protects. The Babylonians made their choice 5,000 years ago. Their foundations are still standing. The choice is yours to make this weekend for $40 with a brush.